All right. So, good evening, students. Good evening, sir. So, you're welcome to this live chemistry class. Today we'll be handling many things. And then it's there for you to ask questions. Your curiosities might be settled in chemistry today. So, the topics, the experiment will cover mostly carbon and yeast compound, and then acid, base, and salt that we have done. We need to see some experiment. Then, before we start, we want to actually check the basics of chemistry, whether it is something that can be done. You know, in chemistry, it's all about chemical changes, where we can generate new substances by subjecting already existing substance to what? A change. Is it not? So, a change in which new substances are formed is what we call chemical change. Then, water is the most common thing we have, and we say that water is hydrogen and oxygen. It's made up of hydrogen and oxygen by the formula H2O, right? Yes. So, we want to confirm if true. This means that the constituent of water is just made up of hydrogen and what? Oxygen. And the only way to do that is you subject water to chemical reaction, it will give you oxygen and hydrogen, because over here, we might do it first. What we use to carry out electrolysis of water is this apparatus here, and this is called Hoffman voltameter. Say Hoffman. Hoffman. So Hoffman, spelled Hoffman, from my initial. Hoffman voltameter. So it is used to carry out electrolysis of acidified water. I cannot see it. Maybe for me. Thank you. So, how do you know? So, Hoffman voltameter. So, it's used to carry out electrolysis of acidified water and also other electrolysis of liquid that liberates gas. So it's made up of two collecting tubes here, and here is the jar, the reservoir. This is where we fix electrodes. In your SS2 you know more. So it comes, though this one is actually the fake one. This is Africa, but I have to improvise. The one they put here will not size it well, because those selling it, they are just selling it there for fancy. They never knew it would be used. So over here is the electrode, and we learned carbon and yeast compound. What are the allotropies of carbon? The crystalline allotropy. So if this happens to be a crystalline allotropy of carbon, which one do you think it is? At least because it is diamond wouldn't be. So this is graphite electrode. It conducts electricity. Another one is here is the platinum electrode. So water, we will split water today to give us oxygen and hydrogen. And in that splitting, we wouldn't be using graphite because oxygen will attack the graphite released. So platinum is the best to be used. So first, we will have to tighten this, close each of the arm with our electrodes. Remember what I call these? Electrodes. Okay. Then I'll fix it here. There is a type where this one acts as the stand, but not this type. This one you can only hang it with your little stand. I hope the camera is capturing the stage well.
Yeah.
Yes. Okay. So the next thing is to fill with acidified water. So we are going to be using water to fill this Hoffman voltameter. So this is calibrated to tell us the volume of gas evolved. though it has little factory error, this should not be accepted. It's a rejected something, but because they know Nigeria is not other scientific, they shipped it. This and this is not equal, but I just allow you because that's even the only one I saw in the market that is manageable. Am I communicating? So we will manage it. What is supposed to be is that here gas will come out, which is oxygen, or depending on how I connect my source of electricity, hydrogen will come in one. But water will always contain hydrogen to oxygen in the ratio of 2:1 by volume. So if here is 2, we are expecting, if here is 2 and here is 4, it means that this is the side for hydrogen and here is for oxygen. That's the meaning. So I'll use water to do that. So let me get bigger. Oh, 15 millimeter here. Okay. Let me use this one. Okay. Here is water, but to increase the conductivity of water, water is a poor conductor. I have to add acid. So that's why we call it acidified water. Not that we are electrolyzing the acid. I'm using H2SO4 to acidify it. Just add more to increase the conductivity of water. That's why I acidified it with what? H2SO4. So sometimes they'll tell you electrolysis of acidified water. It is the same thing as electrolyzing water. So if these things are closed, the water will not go well. So let's try. I have to open them before they go well. See, the reservoir bulb is filled while this is still empty. Why? That's the effect of pressure control. So if I open here, the water will flow down into this. Are you seeing it? Okay. So I will fill it to 0 gradually, meaning I'm filling to the 0 mark, possibly before we start. Yeah, this one is above 0, but this is 0. So what do we do now? It will affect the volume at the process, but I already know this is not correct. It's not aligned well. It will not waste our time. So next is that I will connect this to source of direct what? Current. DC is what we use. This black is the anode, while the white is the cathode. So hydrogen is liberated at the cathode. So if I fix this one here, we are expecting hydrogen. I'm just fixing the wire. I'm not plugging it to source of electricity yet. Remember that AC is not going to be used in this process. Rather, the suitable is AC, alternating current is not allowed. Because the current we use in electrolysis is direct current. It ensures one directional flow of electrons. But in AC, the flow of electron is not directional, it alternates. Maybe if we talk about AC, you see a wave coming up, coming down, but if it is DC, the movement should be one-sided. in one side. So that's what rectifier does. Alternating. You see this alternates with this. So will likely cause problem in bridge. So the best is to use what? This. So I want to, provided that I'm not taking the light. Okay. If you watch closely, you can see bubbles. Are you seeing something? Okay, don't worry. But just know that the electrolysis is in progress already. For some of you, you can gradually maybe come close and do it. There are bubbles. You start seeing that the water will now keep going down. Are you seeing it now?
Yes.
So, but the volume will not be the same. The one with the highest volume is our what? I've closed the tap now. The one with the highest volume is our hydrogen. Then the one with is going to be normal. If this is calibrated well, it should give us the volume of hydrogen to oxygen in ratio of what? 1. So are you seeing it? What I'm carrying out now is what? Electrolysis of water. As you can see already, the volume of this is going down. But don't worry, it will be obvious. So we cannot keep waiting for it. So it's already in progress. I think we find another thing and continue and observe it. If I've acidified it more, the process will be more pronounced. Am I communicating? Because water is a poor electrolyte to give it little time. Okay? So with this, we have decomposed water into hydrogen and oxygen. Don't worry with time, it's going to be very, very obvious. Then the next is hardness of water, or first test for water. Yeah, I think. Test for water experiment. What and what we say we use to test for water? White what? Anhydrous copper 2 which are also sulfate 6. Fine. In the presence of water, it comes what? Blue. So over here is the anhydrous. So it will turn blue only in the presence of what? Water. So if I add water to it, it will turn it blue because of the formation of the hydrated salt. Am I communicating?
Yes.
So maybe I will actually need a watch glass. Okay. It's very, very slow. I wish I would not acidify it more so that, because we don't know how Nigerian never. Yeah, of course. How the source of power will be stable. Very, very slow. That will take me a very long time to go and repeat the process. Okay, maybe we will neglect it and do our test for water. Maybe if it is too slow, we increase the acid. So, at least I hope you can see it. It's somehow an off-white color, somehow. This thing was gotten, this is the anhydrous, while over here is the hydrated. So what's the color? So how did I change this to this? By heating it. How did I change this to this? If you heat it, it will remove the water of what? So this is hydrated copper to also what? Sulfate 6. It's hydrated not because it's wet, it's dry. We are talking about water molecule that is chemically attached to it. Am I communicating? Water molecule that is chemically attached to it will cause the color. So I told you the effect of water crystallization is that it affects the effect of water crystallization, of course, is that it affects the color of the salt and the what? shade. If you look at this thing, if you are there, if you can come close, you see, this one is crystalline, this hydrated, but this is just like ordinary powder. Am I communicating? Yes. So the anhydrous is not crystalline, although under microscope it is still having some crystalline shape. So the anhydrous, we can say that it is non-crystalline. So if I want to change this back to what? If I want to change it back to the blue, what do? I'll add water. If I add any other liquid that is not water or that do not contain water, it will not turn blue. It is only sensitive to what? Water. So this reagent here will turn it because it's aqueous, there is water in it. Remember, the test is only sensitive for detecting water, not detecting pure water. I hope I said this in class. So it detects only water, but not. It doesn't tell us whether water is pure or impure. If you want to determine purity of water, what do? What we use to determine the purity of water is pH meter. Liquids, the purity of liquids is assessed by its what? Boiling point. So the boiling point of pure water should be what? 100 degrees Celsius. Okay? So this is water. If I add it to this place, it will turn what? And that's a positive test for. Have you seen it? So it has turned it blue. So if I want it to come back to anhydrous, what happens? You heat it. But the hydration is exothermic. It releases small amount of heat. The hydration process is exothermic. Therefore, what is here is anhydrous. If I don't close it tightly with time, it will turn what? Blue. Okay? The next thing used to test for water is what? Cobalt 2 chloride pepper. Cobalt 2 chloride what? Pepper. We said that the color of cobalt 2 chloride, we want to use both the pepper and the what? Solid. Look at the solid. This is cobalt 2 chloride. This is a paint because there is water in it. But if I heat it now, it will automatically turn what? Paint. Am I communicating? Yes. So let's try heating it. As I change that thing and add more acid. This is boson burner, tripod stand, and wire gauze. I think you are aware of these things, right? Yes. So, let's check. I think it's all there. Okay. For gas, for safety reasons, you need to know that in any gas system, with the tap, when the tap aligned with the piping is open, but perpendicular to it is closed. You look at the wall, that plaster shows the line of the pipe. So if that thing is at that line, it is open. But if it is opposite it, like this is the pipe now. This thing is straight, that's open. But if I bring it this way, close it. Am I communicating? So this is what we call tongues. You can use it crucible tongues or just place it there. And then you now see that on action of heat, it will turn. Are you seeing it's turning blue already? So we are drying it, we have removed the water of crystallization. When we allow it to still turn back paint, showing that this air is not dry. This is not dry air. Am I communicating? So now I made the pepper before you come by myself. And then To keep the pepper safe, I stored it between fused calcium chloride. Why did I add some calcium chloride into the pepper? The pepper is inside here. Why did I add that fused calcium chloride? Eh? The fused calcium chloride is a drying agent to prevent, in case if any water comes, it will attract it faster so that it will remain blue for me. Believe me, I've not opened it since that morning. I think the thing is dry, right? Yes. Now, for those that didn't see the color well, I hope we can see well. Your own is known. So even now, you can see, don't worry. This is the solid. If I add water to it, it comes back to what? Pink. So over here is, I think we turn off this to reduce the heat and save energy. This is very, very slow. But you are seeing that it's going down. This is unfortunately our, this is hydrogen. Are you seeing this? Multiplying this one by 2. Okay, over here is the pepper. So inside it, I just purposely placed, this is anhydrous. Anhydrous is blue, but hydrated is white. Cobalt 2 chloride is what we are using this now. Come on. Don't be here just bodily present, absent-minded. We use 2 things to test for water. Anhydrous copper 2 tiosulfate 1 6, which I've shown you, or anhydrous cobalt. What's the color of cobalt 2? Pink. Pink. That's the hydrated one, but without water is blue. But in copper, with water is blue. But without water, it's white. But with cobalt 2, this thing shows no water. But if I add it to anything containing water, it will turn pink. So cobalt 2 chloride pepper, we can use it to test for water. Have I made myself clear? So this is not litmus pepper. And if maybe before you go, I will give you, if you take this and keep, before morning is already what? Pink. Morning is even too far. This is water. Maybe we use our wash bottle. Okay, sorry. Let's try. Are you seeing? So it's not because it's acid. This is not litmus pepper. This one will behave the same way in both acid and base because of the fact that there is what? Water. For example, over here we have, okay, we don't have any labeled base here. This is dilute what? HCl. It's not dilute. Dilute hydrochloric what? Acid. Let me get a base. Okay. This is a base, right? And this is an acid. So I will use litmus pepper for us to be convinced that litmus pepper and cobalt chloride pepper are not the same. This one is the litmus pepper acid-base what? Indicator, right? So blue blue litmus. What should be the color of blue litmus in base? Red. Blue. What's the color of blue litmus in base? Blue. So you remember that the cobalt 2 chloride is also what? Blue. So we want to know the difference, that one is not just, this is litmus pepper, it's blue. If I put it in a base, the color will remain the same. Am I communicating? But if I bring this one, this is the base, sodium hydroxide. So, you see, that's touched it well. It is still blue. But if it is that cobalt 2 chloride, there is still edge remaining blue a bit, okay? You can still see little blue, right? If you put it there, see it has turned it pink. So why? Because there is water in it. It is not sensitive to acid or base, but rather is sensitive to water. Your yam, as far as there is water in it, will do the same thing. I think even though the rate is slow, but it is showing us. Are you saying that this one is the one that is liberating hydrogen automatically? This is our cathode, while this is our anode. But I might increase it so that it will give us the gas, because we'll collect the gas and test it. Hydrogen bonds with pop sound, it's very explosive, while oxygen rekindles, glowing, flint. But remember that water always contains hydrogen and oxygen in the ratio of what? 2:1. Are you seeing it now? If you read this, it is always ×2 of what is here. Am I communicating? Okay? But to confirm more, I clean my hands so that the water will not come from my hand. I want to get another cobalt 2 chloride pepper. We use this in biology to test for transpiration. If you place this on a leaf, it will turn pink, showing that water is lost from plants by transpiration. Okay, remember, if this is litmus paper, it's supposed not to change color in base. Very correct. But to tell you it's not litmus, see, it has turned pink. Not because of the base, but because of the water present. So, test for water have been settled. I guess so. How do you test for water? Are you noticing that this my man is going down to pink? Yes. Because there is water in the atmosphere. So it's very much sensitive to water. So what is the application of this? It means that if you are doing any experiment that any little amount of water will cause trouble, you will use this as an indicator. If you want to check if the air is dry, you use cobalt 2 chloride. If we dry this air, meaning if we remove the whole water vapor from this air, this thing will not turn. It will not turn gradually pink. It will remain that what? Blue. And if I open this, all the pepper remaining here will automatically become what? Pink. Okay? So that's it. So the process happening here, I say you call it what? Electrolysis. Meaning splitting. I've succeeded in splitting water into hydrogen and what? Oxygen. This was the experiment performed before scientists tell you now that water is made up of what? Hydrogen and oxygen. If I collect the two gases and spark them together, they will burn and still form back water. That's hydrogen plus oxygen will still form water. Hydrogen is called hydrogen because it is a water former. If you burn it in air, automatically what remains is what? Water. But hydrogen is a gas that we should not mess with. It burns with explosion when mixed with air. Okay? Now let's focus on hardness of water. We discussed about hard water. What is hard water, class?
Hard water is the water that
okay. That cannot form easily with what? So, right? Okay. So, permit me to set this again. I'm removing the source of this to increase the conductivity. I think this was what I used. So that it can give us a. If I open here, the water will still rush by force. See what I mean? Are you seeing it? That's, I've displaced the gas formed. So I want to collect the water back and I know it will pour now because I will open it. What did I call this thing I'm researching? So it's when you go in your higher class, you now see that when they tell you electric, you know what it means. All right. So remember that to whom much is given, much is expected. I was not shown this thing when I was in school. It was only in third school. And when you go home, you ask whenever whether they have done it in school, it's not possible. It's only the drawing. Am I communicating? So I'm doing this to bring science to your doorstep so that you know that it is not only abstract. Okay? I am going to acidify with annoyance. This young man here is not a cool guy. He looks like a cool guy, but he's not a cool guy. You are looking at this as innocent. If you pour water into it, you collect well. That's concentrated H2SO4. And I want it to we want it to leave our sites. We will use it and perform the experiment, which is creating sugar charcoal. We are doing carbon and this compound, right? Yes. And then charcoal is one of the, is it amorphous or crystalline? So the purest form of amorphous carbon is sugar charcoal. So I want to create sugar charcoal with this corn H2SO4 so that you will not run the risk of thing falling on anybody. We're going to hit any moment from now. Hitting. Talking about leaving this down. Okay. I've broken the watch glass. I like that. It's cheap. It's just this one is 300.
Hey.
200 naira. I like that 300 watts. It's better if people get. Can we get sugar from our? Yeah. So that you'll be sure that it's sugar. Who can go there for that family?
Take the sugar. Let us test.
Test the sugar.
Yes.
No, it will be long in the lab. Am I communicating? If anyone can get, you get. So, please calm down and focus. If you can get, I want you to get sugar by yourself so that you know it's sugar. So what am I doing now? I want to dehydrate this sugar with what? Corn H2SO4. Concentrated. That's in the short form. You don't have time for. So you just add it and keep quiet. Before you know it, it will do the cooking of the sugar for you. Don't worry. So it will turn into a black what? Powder. Fear not, it's not going to go beyond that initial graduate. It will do. So we have C12, H11. Am I communicating?
Yes.
So that's sugar. Then what will happen now is that I've added what? Corn H2SO4. It will remove the entire 11 water molecules. leaving behind only what? Black carbon. Am I communicating? Okay. So at least you see it's turning black small, right?
Is it harmful to the skin?
Yeah, it's harmful now because the acid is yet to attack it very well.
But if you pour the acid on your body,
it will dry you, dehydrate you like it's Sugar charcoal is not used to make
so that
that was. So it has started. Now cooking it very well. It's hot, so that's removed between what is now here is the sugar
why is she coming out? Why is she coming out?
If you are heating something, gas coming out. If you are heating something, if you are, okay, but what? Let's be sincere. If you are boiling, I don't like the natural people that take it. This person is acting and making noise. So it has turned into charcoal. And I know the question you are asking me. This steam is being turned to gas. It's just like you are roasting something. The smoke coming out. Am I communicating? So, and if you can perceive something now, are you perceiving one drug you do take?
Yes.
That person calling another is not safe. You come close. So, are you telling me your nose is not? No problem. They won't in charge until you wound yourself. So it is still hot. So that's charcoal, sugar, charcoal. It is still hot. Be careful. So those that say they are not smelling anything. That's smelling like what? Charcoal. So go to the cotton and collect more sugar. If it is a cube, you want to enjoy it more. So this is sugar charcoal and is the purest form of amorphous carbon. If you press it, it's allowed. It's now pure charcoal. Can you do what? Because you are taking us for granted. This is a chemical change, not a physical change. You cannot take it back to sugar. Okay, increase the noise. We have acidified this to an extent. You are not getting extra sugar. If they say you are, don't call anybody. It's because I have this one. If I don't have, you will not do the experiment. This is for this which I know. And that shows how I will continue with it. Just, so if they don't bring anything for you, you will not bring it. I will call it annoying. You yourself, you don't know how to figure out something. So you can now see that the concoction they tell you to take is nothing but sugar charcoal. In the name of Bobo Nishi. It is that's the sour taste because of the unreacted acid. And then it is corrosive and irritating because they have not removed some of the acid. So let us fill this thing back.
Okay.
So to fill, we must have the two things open. I think we might require funnel. This is now acidified water. My fear is if I take annoyance to acidify. Remember, this is water. You don't add water. This is acid. You don't add. If you add water to this thing, you forget where. So because you were taught not to add water to acid, rather add acid to water. Am I communicating? I will add it, but I didn't bring out the protective glass we use for that experiment. But you can't get sugar. I'm not sure whether you can come back to this class. No, if it is too much acidified, the product coming out is not what we want. Do you understand me? Especially at the. Let's go for. Okay. Nothing, sir. No amount of acid will change the product. Let me check if I'm talking to humans. What's the name of this apparatus? Okay. Botanica. What type of cell is it? Electrolytic cell. It is used. We use electricity to bring about chemical reaction. I've overfilled it above 0, but no problem. Our aim is just to. We just pray that Nigerian NEPA is still here. Are they still here? Yes?
We are not sure.
Okay, you see? This is very, very fast. I've seen the speed. So I have to close this. So it is now obvious why I have increased the acid. I have increased the conductivity of the water. So remember this thing now that water is a weak conductor. I've made it more conductive by increasing the what? You can add any salt there to increase the conductivity. I think we are done with this stage. So the next is for hard water stage, right? So we have produced sugar charcoal by did I turn it? Okay, I think I turned the reading towards myself. Are you understanding? The black was here before the other one.
Yeah.
So that's why it is still showing the volume here is more than the volume here now. We not seen it?
Yeah.
So that is it. The next thing is we will try to collect the gas and eventually test for the gas. Okay, I said the next thing is for hardness of water. But before then, we did titration, right? We did acid, base, and what? Salt. And the reaction between acid and base is called. So we can carry out a precise experiment with acid and base using a process known as titration. So in titration, that's the next thing I'm going to do now. Because this Hoffman is not all that too strong. At a level, it will stop the production. So if you check the reading here, if all things being equal, that's why it's calibrated. If here is 4, here will be 2. But I didn't feel them equal in the beginning. At least this one is 4, and this one is still heading towards 2 because it has a factory fault. The if all things being equal, it will liberate equal volume of hydrogen and oxygen, but in the ratio of, in the same rate, because I'm passing the same quantity of electricity through it at the same time. That titration, we are going to do titration and also do preparation of salts from trialization reaction. Remember, we made mention of how to prepare salts. So salts can be prepared from neutralization reaction, and today we are going to be preparing the most common salt we know, which is sodium fluoride. But before that preparation, we have to remind ourselves that these chemicals, I brought them out. This should be our HCl. It's concentrated very well. This is our sodium hydroxide. None of them is friendly. This one is corrosive. When you wash clothes, the thing that corrodes your hand is this particular sodium hydroxide. This one, as we all know, acid is corrosive, especially when concentrated. Even base is also corrosive, but in solid and concentrated form. I made it concentrated so that we will produce a reasonable amount of salt from it. So if I react these two, what am I getting? NaOH plus HCl to give NaCl plus H2O. Now, look at the problem. Is the equation balanced? Yes. The state of matter, aqueous, liquid. Please, what will make this one solid? Because it's for your mind. The thing is moving down. This is now at 3. Please, the thing is calibrated from 0 to the highest, not that thing you are saying. 0 to, I think, yes, that is 50. Okay, 0 to 50. So when I say it's going down, it is producing more. This should be 11. If all things being equal, this one is supposed to be 5.5. So there is a problem in the calibration here, or that some of the gas is leaking here. But here is this is close to 5. So this is a bit slow. Am I communicating? But you have shown today, you have seen today that you can electrolyze water. You know what is happening. Some of you don't understand. Gas is being evolved, which is this thing. There is effervescence occurring, right? Yes. The gas is occupying here, pushing the liquid down to come to this reservoir. Are you not noticing that the level of water in the reservoir is rising? This water falling is entering here. Am I communicating? So if I need to collect this gas, what I do now is just to do what? Put this thing over and open here. The gas will go up here. And then I need to test it with an open flame. If it is hydrogen gas, you will hear pop sound. Am I communicating? And if it gives us that, that shows that the mechanism is correct. But we want it to move down a bit. This apparatus is a bit faulty. But let me wait for it to reach about. If it reaches 16, I will collect the. Remember, if I collect this one without collecting this, the ratio will no longer be the same thing. Am I communicating? As in, it will no longer obey ratio of 2 is to 1 by volume. It was Anton Lavoisier that first confirmed this fact. You don't have what? Shoe. Okay, the kitchen people. They have, but the economy is not allowing them. And the papa is taking the whole sugar in the no problem, but we have seen how to make sugar charcoal. Still there. Funny, I can change this flame to green. I hope you know.
No.
Do what?
Change it to green.
The flame.
Yeah,
Please, I warn you that when you come to chemistry, stop saying that you cannot. I know those are permitted to come here. After warning you, still talk nonsense. So it's not. I just want to entertain you. It's not because of you said you cannot. If it is, you cannot. I want to wipe my hand is shaking. Scared, okay.
Yes, can you guys see?
So, you can change it to red. What I just introduced you to now is what we call flame test. I'm very happy most of you are very much observant. That's copper that I added. Any copper 2 compound will do that. So the color of copper 2 ion in flame is green. So you are learning the science of pyrotechnics. You know firecrackers you used to enjoy in Christmas time?
Yeah.
Giving color flame. At least you can produce green color today using copper 2 ion. So copper 2 compound. Don't try pyrotechnics. Please. It's deadly. But I'm just trying to tell you, you can advise whoever that is doing. So if you see the firecracker or the firework, when they open up, you say, oh, I see green. That must be copper. Or the common thing they use, barium, can also give. Barium can also give green. There are many ions that will give red. Strontium will give you red. Sodium will give you bright yellow coloration. I guess I have to collect some of the gases now. Strontium. I hope I'm not hosting mad people here.
No.
So the thing continues and is keeping the rate. Hydrogen and what? Oxygen. So let me check what's up with hydrogen. Remember, hydrogen is insoluble in water, right? But that means anything here wouldn't be a problem for us. Okay? So that shows we have split this water into hydrogen and oxygen. So I did not. Okay. Do what again? The gas is not yet there. Are you not understanding it? I've used it, so now wait for another one. I've not tested oxygen. You are laughing now. Hydrogen bonds with a pop sound. You have seen it now.
Yeah.
So look at to check if it is this thing that is making that sound or the gas, and returning it back to the fire again. Are you seeing it?
It's green.
No, the unburnt copper is still there. So don't attribute it here. Okay, you like that. Remember why I do this is that I want you to love science, and at young age you start being able to do something. You need to practicalize science. You did your projects, and some of you are currently. In fact, I think I'll go to another class, which is for those that have submitted their project.
Oh, wait.
You are lucky I didn't remember this. This class supposed to be for those that have done their project. Honestly. So maybe you are lucky I used Mark to do that. Remember, if you go out, please don't withhold anything you see here. Tell others. It's not a crime. I just stop them from coming because it will pain them so that next time missing my class is a very big thing. It's not only if you miss my practicals, you know you are missing a lot, as we have seen today. So please, are you now convinced that water is made up of hydrogen?
Yes.
So it remains
Oxygen.
So what did I say oxygen will do? It will rekindle glowing flame. Meaning, if something is burning and you insert it in oxygen, it will burn fast. It will glow it. If you have extinguished it and put it, it will not give all this sound. Today, you have learned test for hydrogen gas. So how can you produce hydrogen? By electrolysis of acidified water. If you electrolyze only water, will it give you hydrogen?
Yes.
Very correct, but it will be at a slow rate because water is a poor conductor. Remember, you can use salt to achieve the same goal I used the H2SO4 to achieve. The salt is just there. It should be the necessity that you enjoy this more. Please, if you play with this, no other center will enjoy this than you are enjoying. Having a life science, everything. So you are even free to ask, how can we do this? Not that unrefined science thoughts. We are talking about based on what we have learned, and we want to know how, whether it can be what done. Okay, at least it's time to collect our oxygen, but let me be patient for you to. I want oxygen to be more. As we are waiting for the oxygen, you know, hydrogen is collecting as fast as what possible. Okay. Is it time? Okay, that means we are. Okay, in titration. I think we look at that titration. In titration, this thing here you are seeing is called burette. Burette. Then this is called stand and clamp. Stand and clamp. Burette. It has tab. There are ones that will come without tab, but with ball. Am I communicating? Then we also need a conical flask, which is what we have here. We call this one what? Conical flask. So we are at the stage of apparatus used in what? Titration. The apparatus used in titration: burette, stand and clamp, conical flask, or you can use volumetric flask. This is called conical. Cone. You put it nickel. Conical flask. Cone. Is that H in cone? Conical flask. Or you call it Ellenmeyer flask. Ellenmeyer flask. Don't say I'm calling conical. If you go look at it, Ellenmeyer was the first to produce this tape apparatus. So Ellenmeyer flask or conical flask. Then we need white tie to observe color changes very, very well. Then we need funnel. Filter what? Funnel. In the filter funnel is just to introduce it into the what did I call this glass? It usually holds the titrant. Say titrant. Or the yes, the titrant. Meaning in most cases it holds the acid. Are you listening? Yes. In acid-based titration, the burette usually holds the what? Acid. The acid is the titrant now. That's the meaning. Anything that is here is called a titrant. But we have different types of titration. But for now, we are just introducing acid-based titration for you. It's an experiment to show reaction between acid and base. That is neutralization reaction. This will help us to measure the amount of acid needed, the volume of acid needed to neutralize a given volume of what? Base. So, which one holds the acid?
The base.
Okay. Then which one is used to measure the base? This is called pipette. Say pipette. The pipette is spelled P-U-R-E-T-T. Pipette. For me, he said, yeah, change it and say the correct thing. Don't have to make it. So, now, this is called pipette. Pipette. How would am I your spelling? You are catastrophic. Who is going? These people going. I think it's getting that maybe you people that is watching, I know you are enjoying it. Please subscribe and share this video. So please, unfortunately I'm going to cut this enjoyable experiment. If you need more, you can start doing it +234 7065166217. I cannot do without you. We welcome you as far as sciences are concerned, both in industrial production, both in quality control measures, in your experiments, anything concerning science, ranging from chemistry, biology, biochemistry, even your medical courses such as human anatomy. Science is life. Let us join hands together to make Africa great. Thank you for watching.